news, everyone!
You guys are not going to believe this. We finally found a tarnish remover for osmium, and it works really well. Well, Historical Marine 45 discovered it.
The bad news, everyone, is
This osmium tarnish remover is bromine. It's not safe to work with.
who likes good news, everyone? Then good news, everyone!
For those of you who are joining me in this series just now, welcome. I am merely taking a log of the tarnish on the surface of this osmium bead. Pretty much all of the tarnish that's on this bead was caused by hypochlorites, whether it be from hypochlorous acid hypochlorites, trichlorhypochlorites, or the hypochlorites in bleach. Actually, bleach is responsible for the least of it, and trichlor is probably responsible for most of it. Okay, just getting a good look at the other side now. Yeah, that tarnish from the molten sulfur is still there, that's for sure. Okay, so Historical Marine has already conducted his test with pure oxygen. He didn't have very much oxygen, and he didn't have very much time. So I'm also going to be doing a test with pure oxygen as well. And it's going to be for a lot longer. Okay, here is my setup. I have the osmium in there. I have a bunch of potassium permanganate, and I have a syringe right here full of 35% hydrogen peroxide. I'll be squirting it in through here. Okay, let's do this. Okay, it should be full of oxygen now. Okay, so what should have happened by now, because each time I did that, there was some very condensed gas in there. The oxygen should have by now, I would think, pushed all the regular air and displaced it out of the vessel. So there's just oxygen in there now, and whatever else. Now, I could have done this test with bleach, but, you know, if I added hydrogen peroxide to bleach, there would be a whole lot of bubbling from the bleach, and it would have splattered onto the osmium and potentially skewed the results that we're looking to get. Okay, it looks like the osmium has already been splattered on a bit. Okay, I'll have to take that into account when we finally look at it. Osmium still looks fine, and I still feel fine. Yep. I think the osmium is still getting splattered with, manganese dioxide solution. Potentially some of the potassium permanganate solution as well. Everything is in order. Okay, so it looks like it is actually producing a lot of water vapor, or at least water in the form of vapor, because it does look like it's recondensing, and I actually hope that it continues recondensing so that way it's just, oxygen in there instead of, mixture of oxygen and water vapor. And so it looks like the osmium is getting coated rather badly in the manganese dioxide solution. I don't know how much oxygen it's actually being exposed to at the moment, or how much of the osmium bead is actually dry. So it's hard to say. This isn't a perfect setup. It's not the worst one either. There's no way around it though. That has to be an extremely oxygen-rich atmosphere in there. It may not be pure, totally pure oxygen, but it's got to be mostly oxygen. And that's enough for this test, I think. Okay, I'm getting slightly worried about, because I'm seeing some manganese dioxide collecting in some of the grooves of the bead, so I might call this test just for now. I might put it back in there since it seems like there's a lot more oxygen to be had with how much permanganate is still left. Okay. Alright. Let's clean her off. Indeed, there was a lot of manganese dioxide on the osmium, but it has been cleaned off. And so far, I do not see any new tarnish on this bead. Let's flip her over. Nope. Nothing that wasn't there before. There may be some permanganate stains on there, I suspect. Oh yeah, I think I'm looking at a permanganate stain right now. It's a mild one at best, but yep, that's a stain, I think. Okay. Yep. For the most part, everything still looks very much the same. Yep. Alright, I am replacing the cap with this much taller pedestal-like surface, this skull-shaped shot glass, which I am willing to sacrifice for science if needs be. Just place it on top, and replace the cap. There we go. Okay. Okay, so now with the current setup, the shot glass, at least the top of it, is surrounded by the outside lining of the plug. So it should be well protected from all the splattering that's going on, and it should be very much exposed to all the oxygen that's in there. Or at least the oxygen that I'm going to put back in there, because I'm going to put more peroxide in there again. Whoa, that's a lot. That's too much at once. All right. Solution. It's been going on for quite a while. The osmium's been in there for quite some time. I hope this is not a test that has to drag on for days and days and days, because I just don't have time for that. So, all right, let's take a look and see how the osmium's doing. Well, the osmium's very wet. That's just for sure. Okay, I'm not seeing any changes. Do you? I don't see any changes. No notable changes. Okay, and when we weigh the osmium, once again, we get the same measurement we've been getting for the entirety of this show. And that reminds me, I'm sure there are some of you who may be skeptical and think, oh, maybe the scale's rigged. What? Sure, someone's bound to think so. Okay, so we're going to take this piece of zinc, we're going to weigh it on the scale. All right, so currently it weighs 6.124 grams. Oh yeah, it lost a lot of mass. All right, so with that elaborate bit of proof out of the way, let's measure the osmium again. Well, look at that. True to my word. Hasn't lost so much as a milligram.